growth occurs when a quantity increases by the same rate R in each time period T. Okay, so it's growing, it's increasing. That's the biggest thing to determine if we're doing exponential growth problem is if it's talking about something increasing in value, increasing in the amount that it is. So this is the formula that we are going to use. Y equals A, that looks familiar. We've been using that. Now what's happening is that B is being turned into something else. It's being turned into a 1 plus your R. And we're going to turn that X into a T because the T is going to represent a time period. So let's go ahead and label this. A, we know already, represents your initial amount. R is going to represent your rate as a decimal. Michaela, I cannot help you right now. T is the time.
Can I come back at 2:15?
Yeah.
Is there going to be homework about this?
Yeah.
Yeah.
Oh.
Are we going to have time to do it in class?
We'll see.
Nah.
All right, so I'm going to give you, so pretty much we're doing a lot of word problems in 11.3. It's all about the word problems, being able to use the formula correctly. So you do not need to write all of this word problem down. Sorry, did I get rid of that too soon? Are all okay?
Yeah.
So here's our first word problem. Click to the next. Whoa, it just happened. It all happened at once.
Is this
There we
on
go.
YouTube?
Yep. All right, so we have a painting that cost $1,400. And the value is increasing by 9% per year. So I would just jot this information down in your notes. You want to write an exponential growth function to model this situation, then find the value of the painting in 25 years. So my T is going to be what?
1 year.
25 years.
25 years.
I want to find the value after 25 years.
Yeah.
Okay, so using our equation, y is going to be equal to, what's my initial amount of this painting? $1,400 times 1 plus 0.09. Perfect. 9% as a decimal is 0.09. Okay. To the what power? 25. What is 1 plus 0.09?
1.09.
It's 1.09. So this is where your calculator is going to come in very handy. Using order of operations, I'm going to do 1.09 to the 25th power.
So wouldn't that just be like 25 something?
1.09 to the 25th power is about 8.623. I'm going to multiply that by 1,400. And we get a final answer of $12,072.32. Okay?
That's not what I got.
That's not what you got?
I tried doing it in my
Oh,
head.
yeah, no. So, that's how much the value of that painting would go up in 25 years. Got it?
That's nice.
Okay. All right. Next one. So now I have a sculpture. It says we got $1,200 was its value in 2015. Right? And it's growing at a rate of what, 8% per year? And I want to find the value of the sculpture in 2022. So what's going to be my T?
7.
So it's 7 years from 2015 to 2022. So go ahead and plug it into the formula and find how much this sculpture is going to be valued in 2022.
I got 2006.
I got that too.
I got that too. Oh, no.
So y equals 1,200 times 1.08 to the 7th. And you get $2,056.59, 60 cents, depending on how you round it. Got there? Okay, so what other things increase in value besides paintings and sculptures? Bank accounts. Didn't we talk about bank accounts on Tuesday? Right? So bank accounts have something that's called compound interest. Okay? Has anybody ever heard of compound interest before?
I heard of interest.
Alexa, can you explain it?
Oh, I can explain it.
You just heard of it? So what happens when you put money into a bank? Your money doesn't sit there.
They're using the trade market.
Right. Well, so if you put it into a savings account, your money is continuously earning money. Sometimes some banks in the past would compound it. So you can either compound it yearly. At the end of the year is when the interest would occur and it would get added into your amount that's sitting in there. Or you could get it compounded quarterly. So that means so a quarter of 12 is what, 3 months? So after 3 months you would earn interest. So that amount would become bigger. And then after another 3 months it would earn interest and that amount would become bigger. And then after another 3 months it would add interest so the amount would become bigger.
Is interest
The more compounding, the better, right? Yeah. So if you got it monthly, compound it monthly, that would be better than getting it compounded yearly. So the more compounds you can get on your money, the better. So if there is a formula for compound interest,
Oh, gosh.
just write, so don't even worry about putting the words in. Just do this and the formulas, right? Compound interest along with the formula. So compound interest is interest that is being earned on your money that you have in any type of banking account.
Do we need these formulas memorized?
These I'll give you.
Okay.
Yeah. The only one I really want you to memorize is the geometric sequence, because I think you guys should be able to memorize that. So, A here represents your amount after whatever it is that's happening. The P stands for the word principal. I know that's not like Mr. Melhorn principal, even though it's spelled the same. Principal is the same thing as your starting amount. So how much money are you starting with in your account? So the same thing as the A. What do you think the R stands for? Your rate. Same thing. Your rate needs to be a decimal. What do you think the T stands for?
Time.
Time. Good.
Then what's with the N?
Now, what do you think the N stands for? What were we just talking about?
Number.
Not the nth term. That was a good check. Our guess. I was talking about compounding your interests, and some options were yearly compounding, quarterly compounding, monthly compounding. So the N represents your number of compounds. So number of compounds. Okay.
So you know when you had that, like, I forget what it was called, but it was during like the, I think it was during the 40s, and like everyone had no money because they all went to like the bank at one time.
The Great
Right.
Depression.
Yeah, that.
So you're either going to most likely have a yearly compound. If it says it's compounded yearly, our n would be what number?
That was right. Right? Like that's one.
If it's yearly, it would be 1. If it was quarterly, my n would be 4. If it was monthly, then it would be 12. If it was daily, what would my n be? 365. We'll pretend it's not a leap year, right? Okay. So that's the number of times your interest is being added into your account. All right, everybody's got this?
Leap years always make me think of
Yeah, when's our new leap year?
Didn't we just had one last year, right? So, yeah.
What does it even do? 3 more years?
Just adds an extra day. All right, so here we go. We got $1,000. I'm going to give you $1,000 right now. Congratulations. We're going to put it into an account that is earning 3%. And it's being compounded quarterly. And I want to know how much money will be in that account after 5 years. So my T is going to be what?
5 years.
All right, so let's plug it into the formula. A is equal to what? 1,000 times 1 plus. What's my rate as a decimal?
0.03.
0.03 divided by what?
5.
Quarterly.
Now.
4.
What?
Your n would be 4. So because it says quarterly, that makes your n equal 4. Number of compounds.
Always 4.
No, it depends on what it says. If it says quarterly, then your n is 4. To the what power? 4 times 5, which would be to the 20th. Because that means that we're technically adding interest 20 times, right? If it's happening for 5 years, 4 times a year, you're getting the interest added in 20 times. That's why it's n times t. All right, so let's work inside the parentheses first. I would do the division before addition, order of operations. So 0.03 divided by 4 is 0.0075. Adding that to 1 gets me 1.0075 to the 20th power times 1,000. So, calculator work. 1.0075 to the 20th power times 1,000. All right, we're not talking about that right now.
Yeah, like what's the
You guys wanted to get to your homework. Stop being a distraction.
I got 3.17 and times 10 to the negative 40th.
Ooh, I got this. Anybody else got $1,161.18? Try it again.
I got that.
Okay. Let's do the same problem. Compound it monthly. Yeah, so if we did it monthly, then it would be 1,000 times 1 plus 0.03 divided by 12 to the 12 times 5. Because I'm just changing it to monthly now to see what the difference would be. So if we change it to monthly, so this would be an example of a monthly compounded. So 0.03 divided by 12 would be 0.0025, so 1.0025. 12 times 5 is 60. So 1.0025 to the 60th times 1,000. I got 1,161 and 62 cents. So how much more money do I make compounding it monthly over quarterly?
Like 50 cents.
Like 50 cents?
Not even.
Not so much. Okay.
You would think it would be a lot.
Yeah, it's not that much more than it would be. So the more money you have in, the more money it would make. Okay? Go with compound interest. Yes? So we can go to decay. So for growth, we're doing 1 plus our rate. What do you think is going to happen for decay? Minus. Good. So for your exponential decay, if you just want to put the formula down, you can just put the formula down. It's the same definition as growth, except instead of increase, it's decreasing. So your formula for decay is the same as the growth, except that it's going to be 1 minus your rate, because we're getting smaller. So I'm going to be getting smaller as we go down. Okay, so you need to think about, well, what things lose value. Have you guys heard the word depreciate before? So sometimes they'll use the word depreciate often. When something depreciates in value, that means it's getting smaller in value. Okay, so everybody got this? All right, so let's do this one. We got a population of a town is decreasing. So there's my first clue that we're going to be doing decay. So my rate is 1%. 1% as a decimal is what? 0.01. Okay, in 2000 there were 1,300 people. And we want to know the population in 2008. So from 2000 to 2008 makes my T be 8. All right, so let's use the formula. Y equals my initial amount. What's my initial amount going to be? 1,300 times 1 minus 0.01 to the 8th power. What is 1 minus 0.01? Or it might be easier to think, what's 100% minus 1%? 99%, so it would be 0.99 to the 8th power times 1,300. Oops, too many zeros. Calculator work, 0.99 to the 8th power multiplied by 1,300. Gets us 1,199.57, but we really can't have 0.57 of a person. So what would you say for your answer? It's about, yeah, about 1,200 people. So that means this town, if it's decreasing at 1% per year, would end up with about 1,200 people after 8 years.
That's a small town.
It's a small town.
What are we, like 2,000? Actually, we're like 2,000.
I don't know what it is, to be honest.
Yeah, at least 4,000.
All right. So try to do this one.
We're like 3,000.
Fish population. The fish population in a local stream is decreasing at a rate of 3% per year. The original population was 48,000 fish. Write an exponential decay function to model this situation. Then find the population after 7 years. Did you get 3,878?
Yeah.
Oh, I didn't put enough zeros in. Sorry, 38,000.
Okay, we're good.
Yeah, 38,783. There we got that. Okay, so growth, decay. Can you pick the difference between the two? If I gave you the following functions, oops, where am I at here? I gave you y is equal to 2 times 1.25 to the x. Oops, I'm frozen, sorry. Would that be a growth or decay function? Why do I know it's going to be growth? Right, so I know that this is going to be growth because this is larger than 1. Can someone give me something to put inside the parentheses that would make it decay?
0.99.
Sure. So if we did y equals 2 times 0.99 to the x, that would be decay because the number inside the parentheses is less than 1. Right? How would you be able to find what the r would be?
Solve for x.
Bridget, what do you think?
It's whatever's in the parentheses, subtract 1.
So this up here, how do we get that number? What's in the formula? It's 1 plus r. 1 plus r needs to equal 1.25. So how do I solve for r? Subtract it, so it would be 0.25. So as a percentage, the rate of increase would be 25%, right? How would I solve for r in this second one?
It's minus 1.
1 minus r is equal to 0.99. So how do you solve that equation for r? Subtract 1. So negative r is equal to negative 0.01, which would become positive 0.01. So r would be 1%. Okay. All right, so I'm going to give you a bunch to do on your own. You ready?
No.
All right. So y is equal to 3 times 1.17 to the x. I want you to decide, is it growth or decay? And then I want you to tell me what the r is equal to. Y is equal to 3 times 0.54 to the x. Growth or decay. And then what's the r equal to?
Do we have to write it all out?
Nope. So tell me what's growth, which one's decay. Yes, you can borrow one for right now. And then tell me what the interest rate, or not the interest rate, but what the rate would be. First one would be what? Growth. Good. The rate would be 17%. Second one would be decay. What would be the rate?
6%.
What was it? So 46%? Okay. Another way to think about it is if I just take 1 minus this number. Here I would have to do minus 1. I have to get it to 100. Would you be able to do that on the quiz? No, Jake? I'll give you another one. We'll do 2 more for Jake. Y is equal to 3 times 0.20 to the x. Y is equal to 3 times 1.99 to the x. So determine whether it's growth or decay. And then give the rate.
Like, do I just leave?
Yeah, let me give you the homework.
Where you going, Nolan?
Doctors.
Oh,
decay rate would be 80%. Good. Second one is growth, and it would be 99%. Good. All right. Last thing we got to cover is half-lives. You guys aren't in chemistry right now, are you? So if I talk about a half-life of something, what do you think that means? So if I start out with, let's say, I don't even know. What do I have here? If we're talking about fluorine, 20, has a half-life of 11 seconds. So for that amount, so let's say that there's a 40-gram sample, okay? And we're going after 11 seconds, it's half of that amount. So after 11 seconds, it now is how many grams? 20, right? That would be a half-life. That's an example of a half-life. So whatever its half-life is, it takes that long for it to become half of the mass. So your half-life formula, if you want to quickly throw this down here, is A equals P times a half to the T power. So if something is decaying by a half, your rate's going to be 1 minus a half. Well, 1 minus a half is 1/2. So if you see the word half-life in the problem, you're going to be using 0.5 inside of your parentheses. Everything else stays the same. That's just the same as taking 1 minus 0.0, or it's not 0.05, 0.5. Okay, so if we have fluorine 20, so it's telling me that my half-life is 11 seconds. Find the amount of fluorine 20 left from a 40-gram sample. So 40 grams is going to be your initial amount. It's going to be 0.5. Now every 11 seconds is when it splits in half. I'm going for 44 seconds. So what do you think this T is going to be? It's going to be 4. Does everybody see why? So if we take that 44 and divide it by its half-life that it tells us, I get 4. So 0.5 to the 4th power is 0.0625 times 40. Means it would be 2.5 grams after 44 seconds. Okay. So if I said if there was a bacteria that had, can I get rid of this? A bacteria that has a half-life of 12 days. Oops, come up here. So we got a half-life of 12 days. And we're starting with 100 grams. I want to know the amount after 36 days. What would you do? What would it look like in the formula? 100 times 0.5, and what would be the exponent? 3. Good. Because how many splits are we going to have? Well, if it splits in half every 12, how many splits will happen? 3 for the 36. Okay, and then it's just a matter of evaluating it. All right.